Hello everyone, myself Anil. Today I'm going to talk about stacks, which is a topic of data structure. Stacks in data structure. Let us see the introduction to stacks. A stack is a linear data structure that follows the last in first out LIFO principle. It consists of elements organized in a specific order. The basic operation on a stack include push, pop, and peek. Stack operations. There are three operations are there in stack: push, pop, and peek. Push adds an element to the top of the stack. Pop removes and returns the top element from the stack. Peek returns the top environment element without removing it, as you can see in the picture. Push, pop, and peek. Visualization of stack. A stack can be visualized as a vertical structure with elements stacked on top of each of other. The topmost element is the one accessible for operation. New elements are always added on top and old elements are removed from the top. Stack implementation. Stack can be implemented using arrays or linked lists. Arrays implementation is simpler and more efficient for smaller sized stacks. Linked lists implementation allow for dynamic resize. Stack implementation. Stacks can be implemented using array or linked lists. Array implementation is simpler and more efficient for smaller sized stacks. Linked list implementation allows for dynamic resizing and is suitable for larger stacks. Array implementation of a stack. In an array implementation, a fixed size array is used to store stack elements. The top of the stack is represented by a variable that keeps track of the last inserted element. Push operation increments the top variable and insert the element at the corresponding index. Linked list implementation of stack. In a linked list implementation, each element in the stack is a node that contains the value and a reference to the next node. The top of the stack is represented by the head node. Push operation creates a new node, update the head reference and links it to the previous head. Let's see the advantages of stacks. Stacks are efficient for managing function calls and recursive algorithms. They can be used for reversing the order of elements. Stacks are useful in solving the problems that requires the backtracking or undo operations. As you can see the example for recursive calls and stacks. Limitations of stacks. Stacks have a fixed size in array implementation, leading to potential overflow. Linked list implementation requires extra memory for storing node reference. Stacks are not suitable for accessing the elements in the random order. Applications of stacks. Expression, evaluation, and syntax parsing. Function call management in the programming languages. Undo and redo operations in the text editors and graphic software. These are the applications of the stacks. Stacks complexity analysis. Push, pop, and peek operation in both array and linked list implementation have at a time complexity of 0 or 1. Space complexity depends on the number of elements in the stacks. Stack versus queue. Stack follows the LIFO principle, while the queue will follow the FIFO, means first come, first out. Stacks are efficient for accessing the top element, while queues are efficient for accessing both ends. Both data structure have a different application based on their properties. Stack versus heap. Stack and heap are different concepts in the memory management. Stacks are used for storing the local variables and functions calls, while heap are used for the dynamic memory allocation. The serve they serve different purpose and have a distinct memory allocation characteristics. Stack best practices. Always check for stack condition before performing pop or peak operation. Uses appropriate naming conversation for stack related variables and functions. Implement error handling mechanism to prevent a stack overflow or underflow. Stack visualization example. Demonstration of stack operation sequence using the visuals. Visuals representation of push, pop, and peak operations. Illustration of how stack elements changes during the sequences. As you can see in the picture, this is the example for stack visualization. Summary of the stack properties. Last in, first out (LIFO) principle, effective for managing function calls and recursive algorithms implemented using arrays or linked lists. Let us see the conclusion. Stacks are fundamental data structure with a wide range of application. Understanding stack operation and implement the crucial for an efficient algorithm design. Stack provide a initiative a way to manage the elements based on the last in first out principle. You can see the stack operations in the right side. Thank you for watching this video. Thank you.